We are also pleased to have Dr. Jonathan Deenik from the College of Tropical Agriculture and Human Resources at UH Manoa here, all the way from Oahu, and Chris Anton from Hāmākua. So, turn it over to you.
Some kale chips? Or the only one?
Anyway, so soil, you got a lot to cover. Can't do it all in 2 hours. A little bit about nutrition, just in general. We're talking about soil fertility. So nutrition in general, starting from things we're familiar with, and then moving in. Soils and nutrition are not intuitive. There's a lot of chemistry going on down there. Don't worry, I'm not going to get into a bunch of chemical formulas. My poor students have to deal with that. We won't spend much time on water, but water is really critical. So I have one slide that I can talk a little bit about it. Acidity, soil pH is critical. Soils of Hāmākua tend to be acid, some more acid than others. Sugarcane left behind very acidic soils. It's not the end of the world. We can rectify that. We can fix it. One thing to remember, soils are resilient. Luckily, because we tend to be pretty abusive in many ways. Now, our goal is to not be that, right? But remember, soils are resilient. And we're lucky as a planet for them. Organic matter is queen. Organic matter is queen. If you do anything, make sure you make good compost or buy good compost, because that will be the most important input into your soil. Any of you large growers, 10 acres, 20 acres, anybody farming 25 acres? Okay, then it gets a little bit challenging, because getting that much compost is no simple task here in Hawaii. Okay?
Not for long.
Not for long. Okay, I like to hear that. So there's some horizon compost making. Very good. Nutrient management. Okay, well, how do we deal with all these different nutrients, some concepts? Fertilizers and soil amendments. So we'll cover a little bit of both. Organic amendments and, your typical, bag fertilizer. Okay, I grew up in Italy, so I have a special place for Leonardo da Vinci. Very special place. Who's been to Vinci in Tuscany? Anybody here? Oh my God, beautiful place. Yeah. Okay, now the Italians are very good at growing food, yeah? Okay. All right. So, for us, it's obvious. This is what we need to grow, right? Water, proteins, carbohydrates, vitamins, fats, oils, minerals, and there are probably a long list. We're not here for human nutrition. The point is we get a good feeling when we feed our children. We try to feed them a balanced diet, right? When I put a plate down in front of my daughter, I tell her it's got all the ingredients for a good meal. Fortunately, she's a good eater. So I don't have to coax her, you gotta eat that. She gobbles it up. But it's balanced, right? All of the components. There it is. Plants are the same. They need a balanced plate of nutrients. The difference is they don't have a digestive tract. That's obvious to you, of course. They have roots, and the roots absorb the nutrients, and the nutrients come in what form? Dissolved. Cations and anions. Good, they brought me a little thing. I was a Peace Corps volunteer for years, and we just had one small blackboard with chalk. Yep. Cations. Calcium is a cation. It's dissolved in water. the plant uses it in this form. Nitrate is an anion, negative charge, dissolved in water, right? Plants must get their elements in the dissolved form. That's an important concept. Now, you folks aren't going to study chemistry, and you're not going to have to write out equations for me, but as you're thinking about your soil and your gardening and your farming, remember, there are factors that affect whether these are dissolved or not. You guys are familiar with coral sand, right?
Yeah.
What's it made of?
Calcium carbonate.
Calcium carbonate. Very good. So, calcium carbonate. Is it a liquid or a solid?
Solid.
It's a solid. Can plants use calcium carbonate? No, they cannot. It must dissolve. Right? And then you get carbonate, CO3, 2 minus, that reacts with water to produce OH minus. That is the liming activity that mediates soil activity. The calcium is the element that goes into the soil solution and the roots can absorb it. Okay? Very important. So you need all of these. Nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, boron, copper, iron, manganese, molybdenum, zinc, and there are others, cobalt, nickel, very, very minute. Molybdenum, did I put it? Yes, it's there. Okay? Now they're all dissolved. Do you have to memorize this? Absolutely not. However, you must appreciate that some soils are deficient in some of these elements. And if they're deficient in one or more of these elements, what happens to the plant? It doesn't grow to its full reproductive potential. It gets weak. It turns yellow. It gets leaves. It's crinkled up. It produces deformed fruit. Have you all seen a cucumber? It's kind of like it goes like this and then it gets real skinny and then goes out. Have you ever seen that? That's potassium deficiency. You don't have enough potassium in your soil. Pretty easy to fix. But if you don't put potassium in, you're going to get deformed cucumber. I eat deformed cucumber, but if you want to sell it, you won't get market value for it, right? Okay, good. So you need all of these elements. Soils, for the most part, have all of these elements in some concentration. From Hilo to Waipio Valley, we have a soil type that we call hydrodans. Doesn't mean anything to you. These are volcanic ash-derived soils that have undergone severe weathering, intense weathering. Weathering from what? Rain. What's the rainfall in Hilo?
280.
280. I got the facts right here. I didn't have to remember it. What's the rainfall right here? About 120, 140, something like that, right? You go up a little bit higher, it gets wetter. You go up higher and higher, it gets wetter, and then you reach the conversion layer, and it gets dry again, right? What does that mean? 180, 160, 150 inches of rainfall for 70,000 years produces rapid, intense weathering. Calcium goes. Potassium goes. Magnesium is still there, but it goes too. So we have soils that are inherently calcium deficient on this coast. People like to blame sugarcane, but that's lame. It's not sugarcane that did that. Those soils were calcium deficient long before my wife's ancestors walked in these gulches and planted kalo. Right? These are 70,000-year-old soils, at least. When were the first humans to the Hawaiian Islands?
About 300 AD.
300 AD. We've got a historian. Good. All right? So, natural processes affect soils. These soils have been impacted by intense weathering, which results in soil acidity, calcium and potassium deficiency, and another thing, these soils are supremely capable of absorbing phosphate. They have the highest phosphate fixing capacity of any soil in the world. There are research papers, scientific papers that made Hāmākua famous in the world of international soil science. Not so good for us because we want to grow vegetables that like phosphorus. But if you're a soil chemist and you want to make a name for yourself in 1950, you write a research paper on the soils of Hāmākua and you become famous. I'll never be famous because I just grow food. Okay, so, schematic. We've got clays, organic matter, and nutrients. Clays absorb nutrients in different ways. The first and most important way that clays hold nutrients is called cation exchange capacity. Some of you may have heard of this. It is just the clay surface there has a negative charge. You see these little white negative things? That's negative charge. Clay surfaces are negatively charged. What does that mean? Right? Positive and negative, okay? So they have a negative charge. When calcium in the soil solution is flowing about around that clay, what happens to the calcium? It's attracted to that negative charge. Cation exchange capacity. This is why soils can hold and deliver nutrients to plant roots, because they have cation exchange capacity. I live in Makaha. It has really good soil. Unfortunately, we just build houses on it nowadays. Very sad. But, you know, you've been to Oahu lately. It's, I don't know what to say anymore. I want to be positive. My wife tells me, you're so negative, Jonathan. My daughter, Dad, look on the bright side of things. The soils of Makaha Valley are reddish-brown. They're called mollisols. Very fertile soils. Okay, they grew great sugarcane in Makaha 50 years ago. There are small farms still left, not too many, and they grow beautiful vegetables. Those soils are inherently fertile. They're almost the opposite of these soils. Okay? Those soils are characterized by very high cation exchange capacity. Why? Because they have a clay mineral called smectite that shrinks and swells. You might have seen some of that if you lived in Waianae. I got a friend who used to live in Waianae in the back there. I won't point him out. But he knows when those soils dry out, they crack. When they get wet, they swell back up. You don't want to build a house on that, do you? Okay. Cation exchange capacity holds nutrients in the clay matrix against gravity and the flowing water. If we did not have this clay property, all of the nutrients that are weathered from the rock and the ash would just flow right through the soil and end up in the groundwater and eventually in the ocean. But clay has negative charge and it holds those. Now, these soils, in fact, the soil that we're sitting on right now is called the O'Okala soil. Makes sense, right? O'Okala's right over there. Yeah, soil scientists aren't stupid. What's the name of the place? They call it the name of the place, right? Okay. Now, this soil has very low cation exchange capacity. Not because of sugarcane or I don't know what. It's because of weathering. Highly weathered soils accumulate iron oxide. That's why they're what color? Red. Right? We have an unusual type of iron oxide in these soils. We call it ferrihydrite because it rains so much here. It's hydrated iron oxide. And that clay has positive charge. You see, when the mainland soils people came here, they couldn't understand what the heck is going on. Yeah, because these tropical volcanic soils here in Indonesia, you have same kind of soils in Indonesia. When the Dutch soil scientists went to Indonesia, they said, these soils are senile. Why? Because they had so little cation exchange capacity. They behaved like an old man. Right? But you can reinvigorate soils like this. Organic matter, number one. Lime. These soils need lime. Okay? Good. So, first thing is clays hold on to cations. Now, anions will flow right by a negatively charged surface, and that's why we have nitrate pollution on our groundwaters. These soils, however, do a good service for us. They hold nitrate because they're positively charged. Okay, so they hold nitrate. That's unusual. Most soils don't. Okay, I'll try not to get sidetracked. But you can see we could spend 2 hours right here. Okay, so clays and organic matter hold nutrients and deliver it to soil solution where plant roots come and grab them. Very simple, right? But the chemistry of these clays is nothing but complicated. Okay? We're not going to get into it. This is a schematic of the type of clay you have here. This is a ferrihydrite. Let's just think of it as a ferrihydrite surface. This is phosphate. Okay? Well, here's phosphate. Let's just imagine this is phosphate. Phosphate loves ferrihydrite. Whenever phosphate sees a ferrihydrite surface, it just makes a very strong bond. And it doesn't want to let go. That's why these soils are often phosphorus deficient. You might go and look, here I'm going to plant my bok choy or my lettuce, and you put it in, you don't add anything to the soil, and the seedling stays about this big. That's it. It doesn't grow anymore. 2 months later, it's still green, but it hasn't grown bigger than this. That's phosphorus deficiency. Guaranteed. Very common in these soils. But it's not that hard to correct. Bone meal, blood meal, chicken manure, loaded with phosphorus. Those are all organic. You don't want to use organic? 046, 0450, triple superphosphate. That'll solve your problem too. So there are solutions. But if you don't manage that soil, if you think, it's just going to grow, it will not. You might think, well, look at the forest, Jonathan. But that's another story. Okay, so this is a system we're dealing with. It's not very simple, but we'll try to get some idea. Water is important. Now, most of the time here on the Hāmākua Coast, things are changing, of course. Things are changing. This used to be a very wet place. All year round. You know, a month without rainfall was unusual. Right? 30 years ago. 50 years ago. Nowadays, things are a little wacky. It's drying out. And in fact, if you've been following the scientific literature, a paper just came out in Nature that showed that Hawaii will be significantly drier by 2050. Now, for soil development, that's a great thing. Because these soils will start to crystallize and form different clay minerals. But, you know, that's going to be at the expense of us, because we need water, right? Okay, so you see, life is full of the yin and the yang. Yeah? So, water. You've got to manage water well. Adding too much water is often the first mistake of us gardeners. Turn the irrigation on, set it 2 times a day, 35 minutes every day, and go away. And then it waters and waters. Well, excess water does what? It leaches through the soil profile. And as that water is leaching through the soil profile, what is it taking with it? Calcium and nitrate and ammonium and potassium. And where's it going? Well, here it goes almost directly where? To the ocean, right? Because the island is too young to have a strong aquifer yet, right? There's no cap rock out there to stop. Not like Oahu, right? I mean, it's 2 million years younger than Oahu, right? So that goes all into the ocean. If you're leaching nitrate and it's going in the ocean, is that good? No. It's feeding what? Algae. What happens when algae die?
Oxygen.
They use up all the oxygen because of bacteria going after them, and the bacteria dies and you get anoxic conditions, the dead zones of the Gulf. We're pretty good at doing that, yeah? Good. All right, so too much water is not a good thing. Yeah, we tend to overwater. These soils have a very good water holding capacity. They have very high surface area. That means they hold water for a long time. Now, of course, in dry periods, you have to irrigate. Okay? Good. Okay. So let's just list a few characteristics of these soils. For us soil scientists, they're very intriguing soils. They really are. These soils that go from Hilo to the rim of Waipio Valley are very unusual. Why? Well, they're made up of a clay type that is quite unusual. It's called allophane and immobile. These are clays that weather directly from tephra. You all know what tephra is? That's volcanic ash. Us guys, we say volcanic ash, the geologist says tephra and gets mad at us. Where did it come from? You know, about 70,000 years ago, 80,000 years ago, this was not a place to be hanging out. It was not a place to be because there were bombs that were falling every now and again. They were coming from where? All of the pu'u on Mauna Kea. If you look up at Mauna Kea on a clear day, you see all the pu'u? Those were exploding pyroclastics in great volumes 70, 80,000 years ago. And in addition to big bombs, who's from Waimea here? Anybody? Okay. You know, if you go dig around in Waimea, be careful because if you're on Parker Ranch, you might hit a bomb, a real one. Yeah. Whenever I go soil sample at Parker Ranch, I got to sign a paper, disclosure. If you die, it's not our fault. Okay. But for soil, I'll take any risk. But you go up there, and if you dig around, you get these big rocks. And they came from those pu'u when they were exploding. That was a while ago. Do you think they might explode again? Could. We don't know, right? Okay. Now, those pu'u also spewed out a tremendous amount of ash. And that ash blanketed these whole coastlines. And in some places very deep. And that ash weathered quite rapidly, actually, into these clays that we call allophane, ferrihydrite. They're amorphous. They're non-crystalline. They're tubular, actually. And they have very high surface area. Okay? But they weathered so rapidly that they lost a lot of their cation exchange capacity, and they developed a lot of anion exchange capacity, which for plant nutrition is not very good. Okay? That's the first thing. So, these soils are low nutrient status soils, inherently. That does not mean they're bad soils. Please, do not take that. I've had talks like this where I've said Hāmākua has low nutrient infertile soils, and people get really, oh, you see my soil's no good. They're low nutrient status, but they can be amended to be very productive. You guys seen the garden right up here? Nice little garden up here. Beautiful tatsoi. Beautiful kalo. But the gardener put stuff in the soil to make it fertile. So you have to put things in the soil. You must. It doesn't happen by magic. Okay? These soils are characterized by extremely high phosphorus fixation. The easiest way to deal with this is to use manure, or fish meal, or bone meal. Any kind of organic amendment naturally coats the clay surface and mitigates, what's the best word I want to say, alleviates that bad negative effect of phosphorus fixation. Yes? Very good. Often, if you're in a food production system, tillage is required. There are no-till systems, permaculture. But you have to employ different approaches. If you till, you can protect that soil so that it doesn't run off. You can have barriers, contour tilling. But you're right, tilling you have to do with caution, especially on sloping lands, in a place that gets 150 inches of rain a year. Okay? Good point. But in a garden type sale, building mounds and putting compost inside there is the best approach. But rampant tilling like in the sugarcane days is not encouraged. That was one of the greatest detrimental aspects of sugarcane production, was harvesting that cane, leaving the soil bare for extended periods of time, and the amount of soil that was lost into the ocean was tremendous. In fact, I just saw a YouTube video. Nowadays, you really can find some good stuff, you know. My daughter turns me on to this stuff. I'm afraid to go on YouTube. What am I going to see? And she showed me this thing on soil erosion. Per year, globally, billions of tons of soil are lost to erosion. So, good point. Good point. Always be cognizant of tilling. Yeah? And water will take your soil away. That's not a good thing. Another thing to be very careful about is when the soil pH goes below 5.5, these soils are prone to aluminum toxicity. Okay? Why? Well, allophane is aluminum rich. The clay mineral I told you about is aluminum rich. And as pH goes below 5.5, that allophane becomes unstable, starts to dissolve, and the aluminum goes into soil solution. If you're growing tea, no problem. Tea loves aluminum. If you're growing blueberry, no problem. Okay? But if you're growing cabbage or taro or beans or peanuts, aluminum toxicity will kill your plants very quickly. It's fairly quick to solve that problem. You either lime to make sure your pH is above 5.5, or you add good quality compost. I began this lecture by saying compost is queen. Organic matter is queen because it solves multiple problems simultaneously. Okay? Good. Sorry I don't have a great picture of a hero soil or a Hāmākua soil. I should. Very quickly, many of you are familiar with the pH scale, I'm sure, but it never hurts to remind ourselves of a few things. Yeah? You know, we think, everything needs to be neutral, balanced. That's the target. Well, in soil, that's not that important. In fact, as you get close to pH 7 and above, you encounter multiple problems. Because as you go above pH 7, iron solubility decreases exponentially, very rapidly. So at pHs above 7, iron precipitates. You know what I mean by that, right? It becomes a solid. And when it becomes a solid, can a plant root get it? No. Do plants need iron?
Yes.
Absolutely. It is an essential element in photosynthesis. Without iron, plants cannot perform photosynthesis. At pH 7, iron begins to precipitate. Okay? Now at pH 5, iron is soluble. But you don't want your soil to be at pH 5, and I told you why. You get aluminum toxicity. So there's a sweet spot. Yeah? There's a sweet spot like everything. You know, you get that Louisville slugger, there's the sweet spot. Well, in soil, there's a sweet spot for pH 2. Anybody know what it is?
5.5 and 7.
It's too wide a range, my friend. I don't want my soil down around 5.5. I might have problems. 6.5. You get the point for the night, my friend.
Yeah,
Good.
Kyle.
Any prize? Okay, 6.5. That's the good target. Does your soil have to be at pH 6.5?
No.
No. Is 6 okay? Sure. Okay? So, the bottom line, if you take away anything from this evening's, whatever I'm doing, you will learn that keep your soil at around pH 6 to 6.5. That's the sweet spot. If it goes below 6, don't panic. If it starts getting below 5.5, do something. Okay? If it's above 7, add organic matter. But most of your soils here will not be above 7 unless you've gotten a little overzealous with your lime applications. But if you want to be in business, you will not do that because lime is expensive when you have 25 acres, right? Very good. Okay, so we're talking about we want pH around 6 to 6.5. That optimizes the nutrients that are dissolved and available for plant use. There is no one number. The cutoff is 5.5. Remember that. Okay? And that's because at pH 5.5 and below, aluminum becomes toxic. This is what happens to a plant root when there's too much aluminum around. That doesn't look very nice, does it? In fact, that's a dysfunctional plant root. The aluminum has deformed the root hair. That's a root hair. It's tiny. Our eyes can't see that. We use an electron scanning microscope to take that picture. So when aluminum is soluble at pHs below 5.5, this is what it does to roots. And that's why your plants die. Okay, that's one effect. The other effect is there's no more calcium. Plants need calcium. Do you know why? What's calcium used for in plants?
Structure.
Structure. Oh, man, this guy should be doing the lecture for us. Yes, structure. Cell walls are made with calcium pectate. So if you don't have enough calcium, the cell wall does not develop and your leaves get deformed. Classic calcium deficiency is crinkling and dying of the very new leaves. Anybody seen that before? Your new leaf just starts to grow and then it starts crinkling and dying. Calcium deficiency. Very common in these soils. Okay? So, aluminum toxicity is a serious problem. And other negative effects are calcium and magnesium and potassium deficiency. Why? Well, for a number of reasons. Leaching of those, because the clays don't have cation exchange capacity, so any water movement through that soil profile takes away the calcium rapidly. Okay? Phosphorus deficiency, very common in acid soils, especially in the Hāmākua Coast area because of high P fixation. I'm repeating myself, aren't I?
Good.
But the more you hear it, the more likely you will remember it. Aluminum toxicity. Is that sugarcane's fault again? No, my friends. No. These soils can be aluminum toxic all by themselves. Yeah? Yes.
Did the sugarcane plantations do anything in particular?
They grew a lot of sugar for many, many years. A lot. So they must have doing something. It gave a lot of people a livelihood. My professor, his parents slaved away on them, and he went to school. He grew up on those sugarcane plantations. My wife's ancestors. So it's not so simple, huh? It's so simple. All right. Now, on the other end, manganese, don't worry about it in Hāmākua. That's an awful problem. You're not old enough yet to have manganese toxicity. Wait around another million years, and that might show up. Okay? If you add too much lime, your soils here will not be pH 7. Naturally. It will not occur. You find pH 7 soils on the Big Island, Mahukona, Hawi. Why? Why?
Dry.
Dry. Making my job easy, man. It's dry over there. No leaching. So it's rich in carbonates, rich in calcium. The dry sides of Kona, lower Kona. Okay? Waimea. pHs of Waimea soils, naturally you go into Parker Ranch that has never been cultivated and you take a soil sample, the pH will be 6.7, 6.8. It's perfect. In fact, if you want to grow vegetables, pack up and move. Those are the best soils in the state. And I argue they're some of the best soils in the world. Right there. Waimea, Kula on Maui. Beautiful. Why are they so much better than these soils? Because Waimea's better. They always tell you that. No, it's because they have not been leached by hot, heavy rainfall. Much drier. It seems like it's wet up there, right? You go up to Waimea and it's always cloudy and foggy. But the rainfall is only about 25 to 30 inches a year, right in Waimea town. Lalamilo, where all the vegetable growers are, is maybe 20 inches a year. No leaching. For how long? 70,000 years. Okay, good. So, you don't want to go above pH 7, because when you do, you get phosphorus deficiency, because phosphorus precipitates with calcium to form apatite, our teeth, our bones, at high pH. Okay? So, the sweet spot, 6.5. When you go above pH 7, you start getting iron, copper, boron, manganese, and zinc deficiency. These are problems. Yeah? Here, you will only encounter this problem if you've really over-applied lime. You know, some folks, they go a little bit overboard. They put oyster shells, then they buy lime, and then they go and they hear the granitic dust or something, I don't know, basalt dust will do it too, and they put that in, and then they put, I don't know, they spend their whole life savings on liming. Yeah? And then the pH does what? It goes above 7, and then they get zinc deficiency, and they complain. All right. Whew. Salt problems. No salt problems in Hāmākua. Why? Leaching. Okay? Leaching. They're leached out. You get a good heavy rain, all those salts are highly soluble, boom, they're gone. Okay? So it's very rare to find a sodium problem in Hāmākua. You can find sodium problems in Hābi, the drier parts of the island. In Eva, they don't farm much in Eva, unfortunately. They just build houses. But those were prime agricultural. Wow. But they did have one challenge. It's dry there, and they accumulate sodium. But as long as you put good quality irrigation water on those soils, aole pilikia. Liming. Okay. I'm going to talk about liming first because we all should get a good feeling for liming. Liming is not the only way to deal with soil acidity. Remember I said organic matter is queen. You can deal with soil acidity problems with compost, vermicompost. But let's begin with lime, okay? Because it's the conventional approach. Lime is what? Well, it's typically calcium carbonate, coral, crushed coral. That's what it is. Okay? And there are crushed corals of varying purity. Yeah? Most of our agricultural lime in the continental United States comes from where? We use a lot of lime in agriculture in the continental United States so that we can feed millions and millions of people, right? I know we're all down on the industrial agro complex and blah, 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 but that's another topic of discussion. Anyway, lime, where do we get it from? We mine it, right? What are big mines for lime? Wherever you find calcium carbonate. Florida. Florida. You heard of these houses that are falling into, sinkholes? Well, that's because that's calcium carbonate that has caves down there. And they're just collapsing. It could be natural, but it could be part of the mining industry. Has anybody been to a potassium or magnesium mine? I'm a fertility guy, so I told myself, I must see a mine. Right? You buy fertilizer. Some of it's OMRI approved. What does that mean? Oh, organic approved, must be sustainable. Well, they get that same bag from the same mine that the other bag came from. So I went to a mine in Carlsbad, New Mexico. You guys know Carlsbad? And we got in an elevator, one of these big industrial-sized elevators. It was kind of Armageddon. I was holy crap. We get in this thing and we go down. I can't remember, 1,000 feet? I can't remember. But you could stop all the way down. Yeah? And we get down to the 1,000-foot level, the door opens, it's dark. And it's this huge, dark, cavernous space where columns have been left behind of that salt. So they just mined it for structure, right, to hold the thing up. And we walked through this place, and I was getting, oh, man. Woo! That's where our fertilizer comes from. How did that come about? Dried up oceans, right? Those salts precipitated out. And if we remember our high school chemistry, different salts precipitate out at different pH levels and different conditions. And so you get a level of halite, sodium chloride. They mine that so you can eat it, right? Then you get another level of potassium chloride. Yeah? That's muriate of potash, 0060. If you're an organic farmer, you can't use it. I don't know why, but you can't use it. Below that, you get potassium sulfate. If you're an organic farmer, you can use it. I don't know why. Somebody here probably knows. Okay? Came from the same mine. Okay. Why did I go down that line? Oh, where is this stuff coming from? Do we have lime here? Can we mine lime here? Kauai High. Can. You can get that crushed coral down there. They crush it up and they bag it and they sell it to you. It's not very high quality lime because it's only about 50% the liming value of this dolopril that you can buy from Pacific Ag or something. This dolomite came from Canada or something, high purity, yeah, finely graded, yeah.
Does it just need to be ground finer?
Well, it's impure. It's not as pure also. It doesn't have the same concentration of calcium carbonate. It's got impurities. But ground finer would help. The more finely it's ground, the quicker it dissolves. If it doesn't dissolve, it doesn't do anything. So some people are always, I can just get my beach sand from Macau Beach and put it in my yard. Well, you could, but how long is it going to take those sand granules to dissolve? 100 years? Maybe. So you buy lime. Okay? Now, liming is important. It's one way to correct poor fertility soils. Okay? So it's a very effective way. You can buy the lime, dolopril. I don't know how much it costs, but it's a high quality lime material. Or you can get it from Kauai High. It's just you would have to add twice as much or 3 times as much Kauai High sand as this ag product that you bought in the store. Okay? So, we want to keep our soils target is around 6 to 6.5. You only begin to consider liming when your pH goes below 5.5 or you have a known calcium deficiency or magnesium deficiency. You can use a soil test to help you on that. We'll get to that in a minute. I hope I can make it there. Okay. You lime to raise soil pH. You want to bring the pH up. And it's chemistry. The carbonate portion of lime, CO3 there, reacts with water to produce OH minus. Yeah? So this reacts with water to create OH minus plus H plus, which is acidity, gives you water. That's the liming reaction. That's the chemistry of it. Don't worry too much about it, yeah? But that's what you're doing. Okay? When you lime, you not only raise the pH, but you increase phosphorus availability automatically. You decrease the soil's ability to fix phosphate. That's a secondary benefit of liming. Okay? The other is, as soon as your pH goes above 5.5, aluminum precipitates. That means aluminum is no longer dissolved. So it cannot attack your roots. Very important. Okay? So you alleviate aluminum toxicity. And if you come from Maui, Molokai, Lanai, and Oahu, you alleviate manganese toxicity, which is a very serious problem of some of those soils. But you don't have to worry. You're too young. By liming, you also increase nitrogen cycling because acid soils do not favor soil bacteria. Soil bacteria go dormant in acidic soils. And bacteria are fundamental to nitrogen cycling. Okay? So as you raise that pH, the bacteria get happy and go to work. Okay? You increase sulfur availability for the same reason. You increase boron, copper, and molybdenum up into a point, right? If you go above 7, then again, they precipitate. So liming has multiple benefits, by raising that soil pH. And importantly for Hāmākua, you supply calcium. It's an excellent source of calcium. And these soils are typically calcium deficient. The typical liming materials are ag lime, which is calcium carbonate. You can use the Kauai High crushed coral. Just apply 2 to 3 times more than what you would with your lime from the store. Okay? Dolopril is a very handy product, one second, because it contains both calcium and magnesium. So you get 2 essential plant elements for the price of 1. And it's a nice product because it's not powder. It's prilled. So it comes out in a little pellet. So when you're spreading it, it's not blowing out in the wind. Yeah? Which is a problem with lime. Because finely ground lime is going to... Who's used finely ground lime before? It's not much fun, right? Okay. Dolopril is pellets. Much easier. Yes.
Okay, so we have a discussion at SBI.
Those are dangerous.
So we're up on the trail about 1,500 feet. And yes, I know we're in line with different. We're having a little cottage trail.
Yeah.
Yeah. So they had the drywall.
Oh, no, don't use that. Look, I got that in the court, so don't use that. That's industrial gypsum. It doesn't line. You get calcium sulfate drywall. Calcium sulfate. It adds calcium, but it does not raise it. Okay? And I wouldn't use drywall in your soil. Yes. Oh, the question here, I think, was something to do about drywall and putting it in your soil as a lining material. Drywall will add calcium because it's calcium sulfate, gypsum, but it will not lime the soil. Liming the soil means raising the pH. Calcium sulfate does not raise the pH. Okay? That was the question. I wouldn't add drywall to my soil. You're not really sure what's in there, actually, unless you get a manufacturer's guarantee that it is pure calcium sulfate. Okay, liming curves. Real quick, this gives you an idea of how much lime do you think you need to add to your soil. Here are two common soils on the Hāmākua Coast. The Kaibiki series, which is just down that way, above the highway, and the Hilo series, which is, of course, outside of Hilo, above the highway. The Ho'okala series, which is right here. The Honoka series, which is down the road. The Maile series, which is higher up. All the Akaka series, which is over by Akaka Falls, they all exhibit the same behavior with regards to lime. How did I get these curves? Well, you just go on to Google. Now they're flying on, I don't know what they're doing. Type in liming Hawaii soils, and you'll get these curves. It's my colleague, Dr. N.V. Hui, who's this madman soil chemist. Wow, is he good. Okay, what does this graph tell us? Well, let's start at the easiest place. Let's say your soil in your field is pH 4.9. That's what that is. Okay? You haven't added anything, your pH is at 4.9. That may not be uncommon, my friends, in these soils. Some of these soils are quite acidic. Most are not that acidic. But it would not be a surprise if you took a soil sample and got a pH of 4.9. Certainly possible. Is that a problem? Yes. If you don't do anything, you're not going to grow much. You'll grow hilo grass. Sure. Loves acid soils. If you want to grow tea, go ahead. But make sure you put some kind of organic matter too. Anyway, what does this mean? I want my soil to be at pH 6.5. There it is, right? 6.5. I need to add 4 tons of calcium carbonate, pure calcium carbonate per acre. 4 tons, that's 8,000 pounds of calcium carbonate per acre. Now, if you do the math, that's going to cost some money, right? Farmers in Waimea typically farm 10 acres. Roger Hirako has 100 acres. If he had to add lime to that, he would have to think about it. So he would have to count, well, what is my growth increase going to be? Right? And sure enough, if he's got a pH of 4.8, he's going to make money by adding lime because he'll grow a lot better crops. That's what these soils tell us, that you need to add quite a bit of lime to get a pH change. If you say, look, I don't have enough money right now, do you have to be at pH 6.5? No. What did I say was a reasonable place to be also? 6. Okay, well, let's come down to 6. 2 tons per acre. Well, that's 4,000 pounds per acre. That's quite a bit less, half, isn't it? Okay? Economics, bottom line. Now, if you're not a commercial farmer, then this really doesn't mean anything. In a small garden, adding 4 tons per acre is a small amount in a bed, right? Yeah, you know how to do that calculation? You just set up a proportion, right? 8,000 pounds per 43,560 square feet equals X over 300 square feet. That's how many pounds you have, right? So, The bottom line is, you see, soils are buffered. They don't want to change. They're like me. What? You want me to do what, Malia? 20 years later, Jonathan, keep telling you. Soil's same thing. They don't want to change. You got to add a lot to change them. Buffered. Okay? It's not like water. You put a little drop of calcium carbonate in water, and the pH goes up to 8.3 instantaneously. Not with soils. Buffering capacity. Good. Lining. Okay, we're racing along. Really sorry, but that's the way we got to go. Yes. How often? Very good. Now, I said that soils are buffered, so they don't like to change. But once you change them, they hang out there for a while. So, depending on how intensively you're farming, you add 8,000 pounds today, the pH goes up to 6.5. It will stay above 6 for a couple of years. Okay? Now, if you're farming intensively with urea fertilizer, ammonium-based fertilizers, they acidify soils. So you might have to add. Typically, you know, our commercial farmers up in Waimea who are growing year in and year out, they're adding lime once every year or every 2 years, once a year. But not at 8,000 pounds, right? Because their pH is maybe at 6, and they just want to get up to 6 pounds. Did I answer your question? Sort of? Sort of. Huh? Hāmākua. They'll last. You get the pH up to 6.5 at least 2 years.
What if you don't add anything?
Yeah, oh, right. It'll last even longer. Well, you got to do a soil test. You know, soils. You do a soil test, you get a pH value, you'll know. They're very easy to do. It's not hard to do a soil test. You can even buy for $100 a very reliable pH tester, and you can do it. And as long as your pH is above what? 6. You're in business. Yes. Very good. So, let's go to organic now. Okay, let's go to organic. Now, I said lime is the conventional approach to raising soil pH. Organic matter does not raise soil pH, but it detoxifies aluminum. And that's the most serious problem associated with soil acidity. So by adding compost, you detoxify aluminum. You add good quality compost, and it almost always has a high % of calcium. So you're adding calcium. Compost, well-produced compost has magnesium. So you're adding magnesium. Am I answering your question? Slowly I will be. Okay, soil organic matter is queen. Okay? Let's just go through it quickly. But before I begin that, you go up in the forest up here. That's beautiful, right? You walk around, and what does the soil feel like? What does the earth feel like beneath your feet? Nice and soft, yeah, and it's cool, and it's moist, and then you put your hand in there, and you smell the thing, and you go into this like reverie. Yeah? Maybe you don't, but I do. Yeah? Yeah? And that aroma is actinomycete. Yeah, you know actinomycete, your friend? That's the composter. Yeah? It gives that unique smell to soil. It's an organism. Okay? You go into a commercial farm that's been applying fertilizers for decades, and you pick the soil up. I still love that soil because it's soil, but I smell it and it just doesn't turn me on. Okay, so you go up in that forest. Soil organic matter is the engine, is the foundation of fertility in these soils. Without that soil organic matter, these soils are basically inert because they're very hydrated in the subsoil. They're not active. So that is the foundation of our terrestrial ecosystem, is soil organic matter at the foundation. So we must always pay close attention to it. Now my friends who are farming 10, 20, 30 acres, they have a very serious challenge on their hands because where do we get organic matter? Yeah? Where do we get it? Yeah? California has huge composting factories, basically. Yeah? and they can disperse it. They have dairies. We used to have, is the dairy still here? Ocala? They have manure. Can you get it from them?
GMO.
GMO. Well, okay. But it's still manure, man. Okay, but they have GMO. Okay. Can't get it though? Can you get it? You can get it? Okay. Well, I would use it. There's no evidence that that manure is going to cause you any harm. You find some, show it to me, okay? All right. Manure is gold, my friends. Gold. Gold, gold, gold. Okay. Cation exchange capacity comes from soil organic matter. So if you want to improve cation exchange capacity, add organic matter. Any kind of organic matter? No. Compost. Yeah, compost. Not wood chips. Compost. Water holding capacity. Organic matter, compost, humus, the fundamental elements, compounds in compost, humus, have huge surface area. So organic matter can hold several times its weight in water. Okay? If we went and collected a soil up here in the forest, yeah, brought it back. In fact, my student did a few years ago. We were doing some studies up in the forest looking at mycorrhiza and rhizobium, and we brought the soil back to the lab, and I asked him, okay, just get water content in the soil first. He went, he did it. I didn't hear from him for like 5 days. You know, I said 2 days, the most. So I'm like, hey, Chance, how's it going? Oh, Dr. Deenik, I had to rerun it. Oh, yeah, what happened? I got some really weird numbers. Oh, yeah, what numbers you get? 300% water holding capacity. You did a great job. That's right. Because these soils have 20% organic matter. And organic matter holds many more times its weight in water. Okay? Very important. So if you want to improve drought tolerance in soil, add organic matter. You will hold more water. Okay? Good. Organic matter provides almost all of the essential plant nutrients. Maybe not in the perfect balance, so we have to tweak it a little bit, but it will supply nitrogen, phosphorus, calcium, potassium, magnesium, boron, copper, nickel, molybdenum, manganese, zinc. Okay? Organic matter detoxifies aluminum. So if you have an aluminum problem, the conventional way of dealing with aluminum is to add lime. Well, man, I don't want a big carbon footprint. I don't want to pay that Matson container. You can detoxify aluminum with organic matter, and you've solved your acidity problem. Okay? Good. And you're enhancing the habitat for soil organisms by adding organic matter, because that's their home, that's their food, that's what sustains them. One of the principal degrading factors of cultivated agriculture is as soon as we start cultivating a soil, we begin to enhance carbon oxidation by organisms, and active soil organic matter is quickly depleted by bacteria and fungi, and the soils become inert because they don't have the carbon. We're not adding it back. We're just adding fertilizer. But every time you put in a shovelful of compost or manure, composted manure better, or fish meal, or vermicast, okay, you're enhancing soil life. Soil life. And remember, soil is a living entity, because in soil are organisms. Billions of them. Billions. Okay, very quickly. Organic matter makes soil form granules. And when soils form granules, they transmit water more effectively. And when soils can transmit water, or allow water to percolate, they do not erode. Very important. As soon as soils start losing organic matter, they tend to become dusty. You've seen, like, you go up to Waimea and you go into those farmed fields, and they have no structure. When they're dry, it's like this dust, and when the wind blows, it's gone. When it rains, it kind of seals up. The water doesn't go through it easily. So organic matter glues clays and silts and sands together to form granules. We call them aggregates. Okay? Very important property of soil organic matter. Yes? Aggregates. Aggregates, yeah? And so one of the really good ways of quantifying a high quality soil is to measure aggregate stability, and we do it in our lab, to help farmers realize, please add organic matter to your soil. As soon as you do, those soil clumps aggregate well together, form granules, and you transmit water. Very important. A soil that transmits water is less susceptible to erosion. Okay? Good. Soil organic matter decreases bulk density. Now, for you and me, that's very important because the work becomes a little bit easier. Your back doesn't hurt so bad at the end of the day because the soil is nice and light.
I'm not a farmer, but for gardening and stuff like that, you got 3 acres of forest on the property.
Yeah.
Can I just go collect some soil from under those trees and say, oh, I've got instant compost?
Well, it's going to be good soil, but it may be deficient in certain nutrients, nitrogen for sure. But that forest you see has rhizobia. It may be, koa forest. And so it's fixing nitrogen. So it's not automatically fertile, but it will have good properties of soil. You might have to add things to it, yeah. When they've done a koa replanting experiments here on the Big Island, they did a bunch of different experiments. And what did they find? If they added nitrogen and phosphorus to a koa seedling,
It's not going to fix.
huh?
Not going to fix.
Well, it's going to grow faster.
Yeah.
It's going to grow faster. So what does that tell you? That soil is nitrogen limited. Now, if you want to make it grow faster, that's the quickest way to do it. Is it the best ecologically? Well, maybe not. Right? Okay. So you make soil lighter by adding organic matter. Hāmākua soils are light to begin with. That's a defining property of Hāmākua soil. And dissolves. That's the name of these soils. It's a defining property. They're light. Their bulk density is about 0.6, 0.5. In some hilo soils, the bulk density is 0.3. So these soils would float in water if you could get them to, right? On the other hand, you get the black soils of Lualuale. They're down in my neighborhood. They're really fertile soils, but they're heavy. And my friend back there has dug them for 5 years. And, hurt his back. That's why he left and he came here. Yeah? So these soils are light to begin with, but you can make them even lighter. Okay? Organic matter increases water retention. Okay? On we go. Organic matter provides nutrients. Okay? He did some nice experiments up at Mealani, which is the same kind of soil as here, almost the same. It's called the Maile series, but it has the same properties as the Ōkala series. Okay? And there used to be a pig farmer in Ahualoa. I don't know if he's back in business. He runs the gas station there. You know that gentleman? He used to have a nice piggery up in Ahualoa. And he made really good pig compost. Yeah? And so we went and took that and just to show farmers that, you can replace all the chemical fertilizers you like with a good pig compost. And we added it to that Maile series and grew beautiful bok choy and green beans and whatnot. It turns out the pig farmer went out of business. So no more compost. Why did he go out of business? Feed. Costs a lot to feed those things. Huh? I'll leave that. Yeah? Maybe yes. I forget. I'm not lying. Okay. Let's see. What do I say here? Okay. So, you provide nutrients with organic matter. You provide cation exchange capacity, which I mentioned before. And you detoxify aluminum. Again, very important. Organic matter feeds the soil. It feeds the soil. That's what keeps all those organisms going. Okay? The koa forests and the native forests on the island are fueled by soil organisms that form symbiotic relationships with the roots, mycorrhiza, rhizobia, and then all of the other myriad organisms that recycle nutrients. So there's a balance, right? Inputs and outputs. What's the input? Leaf litter. Right? Leaf litter, dropping. Decomposes due to organisms, recycles nitrogen, calcium, phosphorus, potassium, zinc, back into the roots. Nodules, biological nitrogen fixation associated with roots, takes atmospheric nitrogen and converts it into reactive ammonium nitrogen. Okay? Farmers used the understanding of natural cycling for millennia. Okay? Some of the best farmers I've ever met in my life are in Pohnpei. You know Pohnpei, Federated States of Micronesia? It's a small volcanic island in the middle of the Western Pacific. that have been farming for about 4,000 years, no inputs, none. Breadfruit, coconut, taro, not one kind of taro, several kinds, yams. A man in Pohnpei is viewed by how big a yam he can grow. I love that, man. Not the Cadillac in his garage or his 80-screen television. I don't know. It's how big a yam he gets. He brings it down to the chief and everybody bows. Wow. 80-pound yam. 6-man carry. No inputs. Why? Because they farm in the forest. They don't cut the forest down. Everything is planted in the forest. We have fancy names for it. What do we call it? Permaculture or something? Agroforestry. And a Pohnpeian says, no, it's a God's gift to us. No name for it. Nutrient cycling in natural ecosystems. Always good to have an appreciation for what happens in the forest. As farmers or as gardeners, we should try emulate forest ecology. But it's not easy. It's not easy because as soon as you put a shovel in that soil, you've changed it. And if you put a tiller in, you've really changed it. Okay? Forests are stable, resilient, productive ecosystems. Yeah? The Pohnpeians knew that, and they didn't disturb it. They plant in the forest. Now, this used to all the forest at some time. Okay? Bringing back forests may be a good option for land use. Not necessarily eucalyptus. Okay, leaf litter. This is Makaha. I bet you didn't realize Makaha is really well. You've probably never been to Makaha. I live down by the ocean and it's dry and hot all day, every day, 365 days out of the year. But we have 20-foot surf out there, so it doesn't matter, right? But you go up in the mountains and it's about 100 inches of rain, koa forests, all kinds of native forests still up there, and the soil, man, it just smells like God. So we have 3 things I want to cover. Cycling of plant nutrients from leaf litter, biological nitrogen fixation, and mycorrhiza. They can all be thought about in a managed farm system. But if you want to manage for mycorrhiza, minimize tillage. Because every time you till, mycorrhiza are fungi. Kill them, and they have to recolonize. Everybody knows biological nitrogen fixation, I'm pretty sure, right? The 3 sisters from our Mayan cousins. Yeah? What were the 3 sisters? Corn, squash, and beans. Right? It was a food system. Right? The beans played a critical role. They're nitrogen fixers. And what does that mean? It's a complex biology, actually, and chemistry, but it's fundamental to life on Earth. It's like photosynthesis. It's the cousin of photosynthesis, or the sister of photosynthesis, because biological nitrogen fixation takes non-reactive nitrogen gas, which is a triple bond, and it doesn't want to change. Really doesn't want to change. Nitrogen gas is stable. It's almost inert. Well, it is inert in its present state. How do we get it into ammonium? And ammonia, which becomes the building blocks for what? Proteins. How do we do that? Well, it turns out there are bacteria, mostly bacteria, many kinds of bacteria, that produce an enzyme called nitrogenase. It breaks that bond. And so you break the bond. Where does the energy come from? Well, it comes from different sources. In this system, the energy comes from the sun, because photosynthesis feeds the bacteria that live in this nodule, and that energy is translated into an enzyme that breaks the bond and produces ammonium or ammonia to make proteins. On the right is a field of sun hemp. Some of you are familiar with sun hemp. It's a cover crop. It grows well in acid soils in the tropics, and if you manage it correctly and make sure you inoculate your soil with the right kind of bacteria, you can enhance biological nitrogen fixation by planting sun hemp. Okay? Okay, now biological nitrogen fixation is the roots performing that. If you want to get the nitrogen that's in the biomass, yes, till it in after. And typically, at flowering or right before flowering. The longer you wait, the more fibrous the plant becomes, and it will give you big headaches in your rototiller. I know. Mycorrhiza. Okay, this is a very ubiquitous association of soil fungi. There are various kinds, many kinds. They infect plant roots, especially most of our trees up in the forest. Many of our grasses are mycorrhizal, so they form an association with this fungi. The fungi have hypha networks that extend out into the soil and basically expand the root area of that plant so they can absorb more water, more nitrogen, more phosphorus, more zinc, more potassium. Okay? And it's really the building block of soil fertility in a forest is mycorrhiza. All of these forest trees are mycorrhiza. If you take away that mycorrhiza, they quickly become phosphorus deficient. In a managed agricultural system, it's not so simple, because every time you're tilling, killing the mycorrhiza. They're associated with roots, right? Minimum till, no-till systems function. Okay? Good. Woo! Earthworms, of course. My golly, good. If you can enhance earthworms. Vermicomposting, of course, is a great way to take your waste from your kitchen and your newspaper. It's garbage anyway, but anyway, you put it all in the thing back there and you make vermicast. Anybody make vermicompost here? Good stuff. For a small scale, it's good. Larger scale, it can get a little challenging, but there are ways to do it. There are ways to do it. Okay? We have nice school programs on Oahu where students are taking quite a bit of vermicast and putting it in the gardens. And that vermicast by itself can fertilize a garden. Okay? What time is it, folks?
10 till 7.
10 till 7. Man, time flies when you're having fun, huh? Okay, we got about... How are we doing? Good?
Yeah.
Yeah? Sure. Sure. As grass clippings decompose, they provide nitrogen and phosphorus. Well, there's going to always be competition. There's always going to be competition. So, you have to manage that. Keeping a nice ground cover around the tree is better than having it bare, for sure. Some covers are better than others. You know this perennial peanut? You've heard of this? That's a great cover within an orchard. Yeah, because it's a nitrogen fixer. Perennial peanut. I think it should grow. It grows well up in Meilani. It grows well, right? Okay. Okay, we talked about biological nitrogen. This is a beautiful koa tree up in Makaha, back of Makaha. Nitrogen fixation is the building block of legumes, right? Taking nitrogen from the atmosphere. I'm not going to spend too much. I mentioned this before. Okay, that's the associate. I like this because, I tell my students, you got to have an appreciation for chemistry. If we don't, we're just missing the boat, man. Take a little time and think about ammonia and nitrogen. We can explain a lot of these things. It's not that mysterious. We can explain it. And if we have an understanding for it, we can appreciate it and value it and take care of it. Right? Malama aina. I won't bore you with all of that, though. Mycorrhiza, we spoke about it before. Building block of forest ecology is mycorrhiza. It all starts in the soils, my friend. My Pohnpeian cousins, they knew all this 3,000 years ago. A note on nitrogen. Let's spend a little bit of time with nitrogen. Oftentimes, nitrogen is deficient for agriculture. Nitrogen is deficient. Why is that? Well, a forest is operating at, let's say, an equilibrium status. If you add nitrogen to a forest soil, it will respond. Plants will grow quicker. But forests and trees are well adapted to low nutrient conditions. And so they produce copious biomass because they have these relationships, mycorrhiza, rich organic soils. Okay? When we till up a plot, we expect growth right away, right? if you are in Waimea, you know, you can look out on the branch lands of Waimea, and when it's dry, in the dry season, what color is the grass? Brown, right? Totally brown. Now the rainy season comes. It's not as predictable as it used to be, but the rains still come, right? When it rains up there, what happens to the grass? How quickly? You know, almost in a day, right? It goes from brown to green almost overnight. Now, if you do a little experiment, take a little plow, don't be destructive about it, but just plow up one line in that pasture and let it rain. And then compare the grass growth in that little plowed line compared to the grass growth next to it. Is it going to be the same? No. It's going to grow much faster and greener in that little plowed section. Why? Well, by plowing that, you've gotten oxygen into that soil. Oxygen feeds bacteria and fungi, and they get really active, and they start mineralizing nitrogen, meaning they're converting organic nitrogen to ammonium and nitrate, which the grass uses, and all of a sudden that thin strip that you tilled has about 6-inch growth advantage on the other. But let's say you till it again. Well, the second time it will show that response again. Let's say you till it for a year, 2 years. Eventually you're going to use up all that organic matter, and it will get lower now. That's our problem. We till and we till and we till, and we don't add organic matter. Okay? So, nitrogen. Most of the nitrogen on Earth is a gas. It's inert. Can't use it. You breathe it in, you breathe it out. 78% in, 78% out. It's non-reactive. Fortunately, soil organisms like bacteria and others can convert that nitrogen gas into ammonia, which can become proteins and become reactive nitrogen that becomes part of the soil organic matter. And so most of our nitrogen in soils is held as proteins and amino acids. Now a protein is a big molecule. Proteins are large molecules. Amino acids can be small. Some plants can directly use amino acids. Right? But plants, for the most part, cannot use proteins either. So you might have lots of proteins in that soil, but it's too big, it can't get into the root. So plants really use two forms of nitrogen, ammonium and nitrate. Where do they come from? They come from the mineralization of soil organic matter. Bugs, bacteria, and fungi perform biochemical transformations on those proteins, and when they die, they release that ammonium into the soil solution. Okay? So it's a natural factory of nitrogen fertilizers. Back in the 1930s, under the employment of the Nazi government, Haber and Bosch, remember them? Yeah, Haber Bosch? They developed a way to synthesize ammonia. Right? It changed the way people lived, for better or for worse. But now, human beings didn't have to wait for bugs and manure. They could make ammonia. How? High temperature and high pressure. How did they get that? From electricity or from oil. And you make fertilizer. And it changed the way people lived. Right? That was probably a defining moment in the history of human beings, was the Haber-Bosch. Some of it was good, but with everything, the yin and the yang, it's not all good, as we all know. But most of us don't farm because of that. We can go and enjoy teaching soil science, or like my father was a linguist, he was a translator, and the guy had all these languages in his head, and he didn't have to worry about eating. He was, just go to the store and buy food. I don't got to farm. Fertilizer. So we like to badmouth fertilizer, right? What's that book, The Omnivore's Dilemma? Oh, nitrogen fertilizer has ruined us all. Well, we need nitrogen, my friends. We need it. Cannot live without it. So, that was my soapbox. Nitrogen availability. Now, many of us are probably inclined to organic farming. which is a good thing. Huh? But you have to be careful, because in many cases, if you're not careful, you will have a nitrogen deficient system. Okay? Let's look at that. Nitrogen availability. Okay, we said that sun hemp, a legume, will make nitrogen more available. And it can do it in two ways. One, it can fix nitrogen through biological nitrogen fixation. That's occurring at the roots. Okay? But also, the biomass, above ground biomass, the leaves, are nitrogen rich. They're about 4% nitrogen. That's pretty rich. The guinea grass that you see outside here, along the roads, that's got about 2% nitrogen. Okay? Coconut leaves have about 1% nitrogen by weight. Okay? But sun hemp leaves, about 4%. Lucina. I think you folks call it koahole. And it's a weed for you guys, right? But if you're a farmer, you recognize that lucina, people in the Philippines have been using lucina for 1,000 years as fertilizer. I was a Peace Corps volunteer in Nepal. We always had ipalipo tree, that's what they call it there. Lucina. Why? Because you made great furniture from it, and the leaves were your fertilizer. 6% nitrogen. Gliricidia. You've heard of gliricidia? Madre de cacao? That's another legume. Those leaves are also 6% nitrogen. So it's a fertilizer, right? Those leaves fall to the soil, get incorporated. My friend said, well, you can incorporate them, that's right. And very quickly, they go to ammonium by bacteria and nitrate. And now they're plant available. So if you're careful, you can recycle nitrogen within your own system. But many times, the nitrogen from sun hemp alone may not be adequate for a vegetable system that likes a lot of nitrogen. Lettuce, for example. Okay? On the other hand, you have to be careful. Well, let's say, this is an extreme case, wood chips. Wood chips are very useful in a garden. What do we use wood chips for? Mulch. To do what? Suppress weeds, retain moisture, protect the soil from the sun, protect it from erosion. But wood chips themselves, if you mix them into the soil, will immobilize nitrogen. What does that mean? Well, the bacteria is in the soil, just like in this other soil, but there's no nitrogen in wood chips. Well, there is, but a very small concentration of nitrogen. It might be 0.2% nitrogen. It's mostly carbon. Those organisms like carbon. Bacteria likes carbon. But it also needs nitrogen to make proteins, right? Where does it get the nitrogen? Can't get it from the wood chips. It gets it from the soil. And a bacteria cell is going to always win over the plant root in getting ammonium and nitrate in the short term. In the short term. Now, eventually, those bacteria cells die and recycle ammonium and nitrate back to the soil. So a year later, you're getting nitrogen again. But in the short term, your plants may look nitrogen deficient. Have you seen that before when you put wood chips around your plants? If you haven't managed for nitrogen in another way, your plants can quickly become nitrogen deficient. Okay? So, the type of organic input impacts nitrogen availability. Low C to N ratio materials, legume leaves, manures, fish meals, blood meals, slaughterhouse waste, these are all excellent sources of organic nitrogen. On the other end of spectrum, coconut fronds, coconut husk, wood chips, sawdust, straw are carbon rich and nitrogen poor. Yes? Macnut husk. Okay, macnut husk really has a tremendous value as an input. It has a huge amount of potassium. That's its value. Nitrogen, it produces great compost, but you've got to let it compost. The husk itself, that's right. That's right. Well, you know, my friend Chris Robb, who's an organic farmer up in Waimea, it's not a secret, so I can tell you. He really makes use of that macnut husk and chicken manure added together to make compost. Beautiful stuff. Macnut husk is a very valuable, recyclable agricultural waste. Do not throw it in the landfill. Go get it. Okay? All right. Woo, man. All right, so here's the example. This is not far from here, folks. This is the Maile soil. This is Mealani, just up the road. You guys know Mealani, the research station up there? Yeah. And we were doing organic matter tests, you know, and getting the hog waste compost from my friend in Ahualoa. Then we got my friend Mr. Botello down in Javi, who has the dairy down there and makes lots of dairy manure, and I got that. And then we got chicken manure from, but he's no longer in business. What was his name? The guy? Davenport. Yeah, so he was making good chicken manure, and we put him in the soil. And you can see, man, where you put plenty manure, that's all we added. We didn't add lime. These soils were acid, 5.1. You know, if you get a soil tester and say, add lime. Nah, just put manure in. Manure is loaded with calcium. The pH didn't change, but you got all the essential nutrients in there, and you detoxify any aluminum problems. So, just manure. What's this? Nothing. So if you don't do anything, you're going to be hungry. You know when you eat bok choy, you like a nice big round plate of it, right? Ooh. Okay, put manure. You don't have to buy fertilizer. You got to get manure, though. Unfortunately, manure is not so easy to come by. Although I heard, is it true, that they're going to start a slaughterhouse down here in Pauilo?
There is a slaughterhouse. There is a...
Oh, rendering plant. Have they gotten it going? Not yet. Push them. Because that stuff is gold. That stuff is gold as a soil amendment. Nitrogen rich, calcium rich. Okay? All right. Okay, so soil fertility, I don't know if you guys can see it in the back. Adequate supply and retention of essential plant nutrients. If your soil has low cation exchange capacity, it won't hold nutrients. What can you do? Add compost. Cation exchange capacity. Okay, good. Oh. Sufficient water, you got to water it, don't put too much in. pH between 6 and 6.5. Organic matter is the foundation of good soil fertility. Organic matter is the foundation. The most fertile soils in the world are organic matter-rich soils. Mollisols in the Ukraine, mollisols in the prairies of the central United States, mollisols from Argentina, the Pampas, mollisols from Waialua. Yeah, now they're just putting corn in there. Let's grow some asparagus or some tomatoes, you know, corn, seed corn. All right. We don't have a lot of time, folks, but we've covered a lot, haven't we? Yeah. We've covered a lot. And I know I've raced through it all, and you've been very patient with me. And it might be a blur. But here's some things to think about. There are many ways to put nutrients into soil. Just like, who's a cook here? Well, I cook. I love to cook. I don't like recipe books. Who likes a recipe book? I don't follow a recipe. I just get this feeling. Yeah, okay, I'm going to put a little bit of that. And maybe it's because I lived in Italy. Do you think Italians follow a recipe? Absolutely not. È un casino, porco Dio. Ma metti questo, vediamo con questo. Right. Adding nutrients to soil can take many forms. There's no one way to do it. Some people will say, you've got to be Korean natural farming. That is the only way. If you like that way, do it. No problem. But there are many ways. That's the key point. But there are 4 principles that I think are important. You can use them any way you like, but the principles are fundamental. The first is, before you even decide what soil, the first thing is, what is my soil like? Does it need anything? You know, if I had bought some land, if I were lucky enough, and my wallet was thick enough, it certainly is not, but if I had lucky enough to get 1 acre in Waimea, that first season, I wouldn't do much to that soil. I would till it a little bit, put a little water on it, and plant. And it would grow really well. Why? Because that soil is inherently fertile. If I added, you know, Korean natural farming, God knows what they're putting in vodka. You know, would I need to do that? No. The soil's fertile. But if I kept doing that, I'd be in trouble pretty quick, right? Because the second crop would be just a little bit less, the third crop would be less, And by the 4th crop, I'd have a tiny little bok choy, and I would be a very poor steward of the land. Aole, malamaay na kia, right? I'm not taking care of that land. First, know what your soil is. First. We're going to get to that in a minute. Then, what do I need to add? And what's the best way to add it? Like my friend in the back said, do I want to bring lime from Canada? Can I get it here? Do I need to add lime? Maybe I can just use compost. What? So, right source. What are you adding? Are you matching it well? I have some friends on Kauai, you know. I think they lived in 1968 for too long. Okay? And they're telling me, oh, Jonathan, I got this granitic dust from Jasper National Park or something. I don't know. Yeah? And it's going to make my soil great. Well, why are you getting granitic dust? Just use the basalt dust that's right down the road. Oh, no, it's got... So you see what I'm saying? Yeah. Okay. How much? How much do I add? You know? The Goldilocks thing. Not too much, not too much, just right. Right? That's it. You add too much, you're going to pollute the world. I don't care if it's the most highly prized organic fertilizer. If you add too much, you're going to have excess nutrients. And where do they go? Mostly 2 places. Either up into the atmosphere and contribute to global warming, or into the groundwater, or into the water body. I don't care if it was chicken manure, Korean natural, I don't know what, or nitrate from a bag. It all ends up as the same thing, a pollutant. Right? Good. Next, timing. When should I add it? Do I add it all in the beginning? Or do I put some in the beginning and then top dress? Okay? When do I add it? Can I fertigate it? Maybe I can put it through an irrigation line. There are many ways of adding that nutrient. And then lastly, where? Do I just put it on the surface of the soil and go home and watch TV? Or do I till it in? Or do I band it in a band right down the row at 6 inches deep? Or do I put it as a plug right next to the seedling? Many choices, right? But these are the questions that you need to be thinking about. And nowadays, if you have your little computer and you're proficient like my daughter at Google, you can find almost any answer. Some of them are better than others. But that's up to you to decide. Soil test. What time is it, folks?
7:12.
7:20. At Gulamayo at 7:30, I got a holo because I got to catch a plane. I got to teach tomorrow. 8:30. Okay. This is my friend Ray Uchida collecting soil sample. We do a lot of this. Yeah, it's fun. You know? We collect soil tests to determine what's in the soil. Now, soil tests, you know, they're valuable, but they can't tell you everything. The soil is too complicated. There's too much going on down there for a soil test to tell you everything. Even with our own body, right? We go to the doctor and we get different tests done. Now, you know, I turned 50, so I got to do this and I got to do that, and my doctor says this and that, and I get cholesterol this and blah, blah, blah. And supposedly it's going to tell me I'm doing something right or I'm doing something wrong, right? Some of us believe it, other of us ignore it, whatever. Soil test is much the same. But there is an underlying principle. You're measuring plant available elements, calcium, magnesium, potassium. And so it can guide you. Yeah, it can guide you. We use soil tests to make fertilizer recommendations. They can be used to make organic fertilizer recommendations or, you know, conventional fertilizer recommendations. But I recommend, for a gardener, I'm not sure it's that important, but if you're just beginning and you're having troubles, then of course a soil test is important. Me, in my yard, I've never done a soil test. I grew up growing with my mom. My mother has never done a soil test, ever. She grows beautiful vegetables and flowers. Why? Because she's in the garden every day. She knows those plants and her soil like the back of her hand. And she knows, wow, you know, I didn't add enough horse manure. That's what she used. She didn't do soil tests. So, for some of you, it's not that important. For a farmer, it's a very valuable tool because you're operating on an acre, 2 acre, 10 acre, where inputs cost money. Yeah? Soil tests help farmers manage optimize growth and minimize environmental contamination. That is the value of a soil. How do we grow our food and match nutrients with plant requirements? That's the objective. Why? So that we don't pollute our world. But we feed ourselves. What's the population? 7 billion. I lived in sub-Saharan Africa. You know, in some places I was hungry. Nepal, I was hungry for 4 years. Sometimes one meal a day. I weighed 120 pounds. But I was happy. Taking a soil test. You can go online and find this out. But if you're going to take a soil test, think about it. Yeah? Is the soil the same across an area? No, it can vary. It varies based upon what vegetation is there, the slope, the drainage, the color of the soil. If this soil has one color and the soil over there has another color, would you mix those two together? No, because they're two different, very different. So you have to think about your soil collection procedure. There's a handout online that you can go look up, collecting a soil sample, UH something, and it'll give you a good background, right? You've seen it? Does it help you? Yeah. It does. Ask my friend right here, he can help you. We use a soil test to tell us whether the nutrient is deficient or sufficient. I know this is a graph, many of you may not be used to looking at graphs like this, but when the soil test is low, down here, 4 parts per million, 5 parts per million, the soil test report will tell you that it's low. That means you need to add that element. Why? So that you can get optimum growth. This is plant growth, relative to 100% yield. If you want optimum growth, you have to have at least this much phosphorus in the soil, for example. Just like your blood test. If your cholesterol is above, what's the number? 200? Right, they tell you, Rada, no more beer. Or get off your ass and do something. Or change your diet, right? If it's below 200, what does the doctor tell you? My God, you're good. Right? Same thing for soil. If you're below a certain number, I'm going to tell you, raise phosphorus. How? Add fish meal. How much? That's the next question, right? We can calculate that. The point here is more is not better. Always. You keep adding phosphorus, is your yield changing? It's like a typical economic, is that I can't remember what you call it, but diminishing returns. There we go, right? Same concept. But the thing with adding too much fertilizer, you're not only not getting the yield you want increased, but you're adding what to the environment? Pollution. So even us, simple people, little 25 by 10-foot garden in the backyard, if I'm not careful and I keep adding fertilizer, where does it end up? I live right by the ocean. It goes right into the coral substrate below my house and goes right to the ocean. Almost in a day. I'm organic, bro. Doesn't matter. Nitrate is nitrate, whether it came from fish meal or a bag of potassium nitrate fertilizer. Okay? So, we did a survey, Central Oahu, Mililani. Used to be farmland. Now it's what? Houses. Mega houses. And those guys love their green grass. Most people do, right? It's nice to look at a green grass. I don't care myself, but how do they make their grass green? They add ammonium sulfate. Where do they buy it? Lowe's. Cheap. Cheap, man. One bag, like what? I don't know, $12. They spread the whole thing out. Then they come back 3 months later. They spread the whole thing out. We went and interviewed these folks, and we found they were adding over 1,000 pounds of nitrogen fertilizer per acre per year. Why? Because they're not paying attention. They're not paying attention. That excess nitrogen goes where? Down into the soil, and it leaches. You multiply that by 10 households, 20 households, 50 households, 100 households, and you have a potential problem. Are they doing it meaningfully? No. They don't want to pollute the groundwater. Nobody would want to do that. Do farmers pollute the environment intentionally? I don't think so. Do you know farmers? I do. They would never say, I'm doing this because I want to. Absolutely. So we use soil tests to guide us. Plants use nitrogen in different amounts. They use phosphorus in different amounts. Here's some examples. Corn loves nitrogen. He loves it. You fertilize corn with nitrogen, man, it takes it up and it produces big ears and we're all happy. Yeah? But peanuts or onions use half as much nitrogen. Look at cucumber. You can get away with 50, 60 pounds per acre of nitrogen fertilizer to grow cucumber. They don't need a lot of nitrogen. They like potassium. Look at potassium for cucumber. 300 pounds. Look at banana. 900 pounds of potassium per acre. It is known. You fertilize your banana patch well with potassium, you will get good quality banana. I love banana. I love banana. I grow banana in my yard everywhere. It's a forest of banana now. It blocks out my neighbors. And it gives me beautiful bunches. All I do is every now and again, if I can get seaweed, I just dump it on there. Rich in potassium. Okay? So, plants need elements in different amounts. You can find all this information on the internet. You can find it. Soil test. This is the UH soil test printout. We're working on it. It's going to change. We're going to make it a little bit more intelligible. I know. How long have I been saying this? Okay, what does this mean? This will be the last thing I cover. Okay? This soil has a pH of 5.6, phosphorus of 9.8, potassium of 200, calcium of 795, and magnesium of 280. That's what the lab determined. You sent that soil in, it gave you those numbers. This line says, well, you should have a pH of about 6.2. That makes sense, right? We said between 6 and 6.5. So do we need to do something about pH? Probably. We're above 5.5, but we're not close to 6. So raising it up to 6 would be a good idea. Phosphorus should be around 7. We're at 9. Man, we're almost 10 times below what we should be. We better do something about phosphorus. Potassium, well, we're a little low. 300 is what we should have. We have 200. Calcium, we're way low. 795. The target is almost 3,500. So this soil is calcium deficient. That would be common for these soils. You get a soil test back, it's going to be calcium deficient. My recommendation would get good compost in that. You will solve your calcium. Okay. So, they come down here and they tell you now, add fertilizer, 10-30-10, lime, dolomite, gypsum, magnesium sulfate. This was made for conventional farming. It's not for the organic farming. But now you can take that information and think, okay, compost or manure compost, vermicast. Okay, we can make some calculations. That's how we use a soil test. Organic or conventional? Organic, many advantages of putting organic matter into the soil. We heard that all evening. So you add organic matter to soil, you're doing many positive things to soil. On top of that, you're feeding it, you recycle local materials. Instead of putting it in the landfill, it goes into your yard, or it goes into your orchard, or it goes into your vegetable garden. Okay? We need to be developing technologies that take our human waste and convert it into fertilizer. There are technologies. Yeah? Important. Conventional. Now, we've been farming conventionally for half a century. We produce a lot of food. But there are drawbacks, right? There are environmental drawbacks. Soil quality drops. Soil acidity goes up. Leaching of nutrients becomes a problem. Creation of dead zones in the ocean due to runoff, right? Why do people farm conventionally? Well, chemical fertilizers are relatively cheap. They are cheap. Compared to organic fertilizer, it's quite a bit cheaper. You buy a bag of feather meal that's 13% nitrogen. I'm not sure what you pay here in Hilo, but on Oahu you're going to pay $20 to $30 for that bag. Maybe more, $40. To buy a urea, 50 pounds of urea, 46% nitrogen, $15, $16. It's almost 3 to 4 times more nitrogen. It's cheap. I've worked with the Waimea growers for almost a decade. How do we reduce chemical inputs? They understand that organic matter is valuable. But at $80 a yard, cubic yard, they're going to go out of business. They have all these costs associated with labor and other things. And they got to compete with who? California.
Yeah.
Ooh, now this becomes challenging. So it's challenging to get that organic matter. Cost and availability. Cost and availability. What time is it, folks?
7:24.
7:24. You know what?
Questions?
Let's have some questions. First of all, thank you for listening to my ranting. Mahalo, Yaoko.
Thank you.
And I'm sorry I got to leave so quickly.
Thank you.
But if there are questions, please, let's spend some time, 10 minutes. Yes.
Top dressing work for your trees? I mean, I have trees that haven't been fertilized in a few years. Top dressing, is going to work good, and then mulch it?
Okay, good. For things like nitrogen and potassium and calcium, top dressing works. Phosphorus, the thing is that phosphorus is not going to move down into the subsoil. So if you top dress, I would mulch on top of it so that the roots can grow up into it and be protected by that mulch. Another way is to stake in pukas, but it's more work.
What percent of phosphorus is actually absorbed by the plant, or is it just the environment?
Okay, so when you add phosphorus fertilizer, what percent goes into the plant and what percent?
Yeah.
Okay, that's a very difficult question because phosphorus chemistry in soil is very complicated. In these Hāmākua soils, triple superphosphate, 90% of the added superphosphate is sorbed onto the soil right away. That's why in the beginning, fertilizing for phosphorus in these soils is very expensive. And so that's why I would say don't use chemical phosphorus on these soils. Use manure. Okay? But you've got to be adding manure at, this is the quantities, we're talking 20 tons per acre, 40,000 pounds per acre. That's the kind of rate, in the beginning, that's the kind of rates you've got to start with. And that becomes prohibitive when you're on a large scale. In your backyard, it's not that bad. It's maybe 40 pounds, 50 pounds, 100 pounds. Somebody had, yes? So, good. So the mycorrhiza that I was mentioning, those fungi that infect plant roots, they extend the plant root sorption capacity and grab phosphate that the root wouldn't be getting and bring it to the plant. Yes, that is one of their principal roles.
So if you're calcium deficient in soil and you add calcium, when do you check again to see where the pH is?
Okay, good. So the liming reaction. If you have a soil that's a pH below 5.5 and you want to add lime, how long does the reaction take for the pH to rise? Well, that depends on what you added. If you added the Kauai mined sand, it's going to take longer. Okay, the reaction is slower. If you add dolopril, the reaction is pretty quick, within a couple of months. Weeks, because it's highly soluble and reactive.
Often on my soil tests, my pH is in pretty good shape going by, and we have lots of organic matter. My calcium levels can be lower, and the recommendations I usually get are apply gypsum rather than apply lime. Could you speak a little bit to the difference between applying calcium versus applying lime?
Good. This is a common situation. Like the gentleman says, he gets a soil test result back. The pH is adequate, 6, maybe 6.5, but his calcium levels in the soil are low. So the testing lab says add gypsum. Why? Well, gypsum is a good source of calcium. It's calcium sulfate. They recommend gypsum over lime because gypsum will not raise the pH. It will supply the calcium but not raise the soil pH. Remember, you don't want to raise the soil pH too high, right? Because if you do, you get iron, zinc deficiency. So they recommend calcium sulfate gypsum for the calcium, not for the pH.
So with irrigation, is there a amount that has to be done? If you irrigate, I think if you irrigate too high, it's pretty often irrigated, but I just want to know.
That's an excellent question. Now, managing soil water is not simple at all. There's no simple way to do it. There are soil moisture probes, but they're expensive, the good ones. They're expensive. You can use those, but they're going to cost you several $100s, maybe into the thousands of dollars. Okay? The other way, which is, it's a little bit complicated, is if you measure pan evaporation. So if you can measure the amount of solar radiation that's evaporating water from a pan of a known volume, you get an evaporation rate, you multiply it by a coefficient of like 0.6 something, and you get potential evapotranspiration rate, and then you add the deficit. But not easy. That's why we're mismanaging water. Growers in California, where water is really a problem, they're very careful. They spend the money to put soil moisture probes in their fields. We should be doing that, but it's expensive. We should do it, though, for better water management.
Can you discuss rainwater versus the water supply water that has the chlorine in it?
Okay, good. Chlorine, when exposed to sun, volatilizes. Right? So, the chlorine that's in the treated water, fairly quickly, when it's exposed to the environment, the chlorine dissipates. Okay? Rainwater has very low chlorine, but, you know, we've been irrigating with municipal water for decades and decades. No negative effects. That's 7:30. Pardon? 7:30. I got a few more questions. I've pushed the Kilo's pretty mellow, yeah? It's not like Honolulu. We got to go. She's driving. We got to go. Thank you all, folks.
Thank you. Okay, well, mahalo nui ya'oko for coming out. If you could just take a minute or two to fill out our practical ag for Hāmākua evaluation form, that would be fantastic for our feedback. If you don't have a poster, you can grab a poster.
I'm leaving this PowerPoint presentation on this computer if you want to talk to them.
If you don't have a eval form, they're right up here.
Just don't put it on YouTube.
If you haven't turned in your participant enrollment form, the little half sheet page, just set it up on the desk as you leave. And then I also should say that Practical Agriculture for Hāmākua is a program of Kilo Hāmākua Community Development Corporation, sponsored by the County of Hawaii.
And if anybody wants to help close windows or put back
County of
tables,
Hawaii
that'll be
Department
awesome
of
too.
Research and Development in collaboration with La Hawaii Community Public Charter School. And I do have Tom Doe here, who has an announcement about